Our solar system is a vast and mysterious place. It's filled with planets, moons, and countless other celestial objects. Among them, Saturn and Jupiter stand out. They are the giants of our solar system. Saturn, with its majestic rings, has captivated astronomers for centuries. Jupiter, a swirling storm of gas, is a true behemoth. These gas giants are more than just planets. They're time capsules, holding secrets to the early solar system's formation. Imagine a scenario, a cosmic event of unimaginable scale. What if Saturn and Jupiter collided? What would happen to these majestic planets? What would be the impact on our solar system, including our very own planet Earth? Join us as we delve into the science behind such a celestial clash of titans. We'll explore the possible consequences, both immediate and long-term, of this hypothetical yet thought-provoking event. Saturn is best known for its stunning rings. These rings are made up of countless particles of ice and rock. They range in size from tiny grains to massive chunks. The rings are so large and bright that they can be seen with a simple telescope. But there's more to Saturn than just its rings. The planet itself is a gas giant composed mainly of hydrogen and helium. It's the second largest planet in our solar system. Only Jupiter is bigger. Saturn is also home to a variety of moons. These moons come in all shapes and sizes. Some even have their own atmospheres. Saturn's atmosphere is a turbulent place. Storms rage across its surface, some larger than the entire Earth. These storms are driven by powerful winds and internal heat. This heat is a remnant of the planet's formation. Jupiter is a true giant of a planet. It's more massive than all the other planets in our solar system combined. If Jupiter were hollow, you could fit over 1,300 Earths inside. Jupiter is a gas giant just like Saturn, but it's much larger and more massive. It's also much more active, with a constantly changing atmosphere. One of Jupiter's most notable features is the Great Red Spot. This giant storm has been raging for centuries. It's so large that you could fit several Earths inside it. Jupiter has a powerful magnetic field. This field traps charged particles from the sun. These particles create intense radiation belts around the planet. Jupiter's immense gravity has shaped the solar system. It has shepherded asteroids and comets, influencing their orbits for billions of years. Collisions are a fundamental part of our solar system's history. Early in its formation, our solar system was a chaotic place. Planets were still forming, asteroids and comets were abundant, collisions were commonplace. These collisions were driven by gravity. Gravity is the force that attracts objects with mass towards each other. The more massive an object, the stronger its gravitational pull. When two objects get close enough together, their gravitational forces can pull them into each other. This can result in a collision. The outcomes of these collisions vary depending on the size, speed, and angle of impact. Some collisions result in the complete destruction of one or both objects. Others result in the formation of new objects such as moons. Still others result in the objects merging together. Section 5. The day the sky changed. Imagining a Saturn-Jupiter collision. While astronomically improbable, let's imagine a scenario where Saturn and Jupiter are on a collision course. Perhaps a rogue star passes through our solar system. Its gravity disrupts the orbits of the giant planets, or maybe a series of smaller gravitational interactions nudge Jupiter and Saturn closer together over millions of years. As the two planets draw closer, their gravitational forces on each other would increase dramatically. This would cause them to accelerate towards each other. The closer they get, the faster they would go. The first sign of the impending collision, visible from Earth, would be a change in the night sky. Both planets would grow larger and brighter. Saturn's rings would become more prominent. The collision itself would be a spectacular event. The two planets would smash into each other at incredible speed. The energy released would be unimaginable. It's impossible to fully comprehend the scale of such an event. Section 6. Cosmic chaos. The immediate aftermath. The immediate aftermath of the collision would be a scene of utter chaos. The two planets would be completely destroyed. Their atmospheres would be ripped apart, their cores would be shattered. The remnants of these once mighty gas giants would form a massive cloud of debris. This debris cloud would be incredibly hot. It would be glowing brightly in infrared and X-ray wavelengths. It would take millions of years for this debris to cool and disperse. The gravitational effects of the collision would be felt throughout the solar system. The orbits of the inner planets, including Earth, would be disrupted. Some planets might even be ejected from the solar system entirely. The asteroid belt lying between Mars and Jupiter would be scattered. Comets in the Kuiper belt beyond Neptune would be sent careening through the solar system. Some of these objects could potentially collide with Earth. Section 7. Ripples through the solar system. The long-term effects of the collision would be just as profound. The debris cloud from the collision would eventually coalesce. It would form a new object in our solar system. This object would be incredibly massive. It might even be massive enough to ignite into a star. If a new star were to form, it would drastically alter the dynamics of our solar system. The remaining planets would be caught in the gravitational pull of this new star. Their orbits would be completely different. Even if a new star didn't form, the remaining planets would still be affected by the collision. Their orbits would be altered by the gravitational pull of the debris cloud. This could lead to planets colliding with each other, or a planet could be ejected from the solar system entirely. Section 8. A new cosmic order. In the aftermath of this hypothetical collision, our solar system would be a very different place. The once familiar arrangement of planets would be gone. A new order would emerge, shaped by the forces of gravity and the remnants of the collision. The asteroid belt, once a relatively stable region, would be in disarray. Asteroids would be scattered throughout the solar system. The risk of asteroid impacts on Earth would increase dramatically. The Kuiper belt, a region of icy bodies beyond Neptune, would also be disrupted. Comets would be sent on new trajectories. Some of these comets could potentially pose a threat to Earth. Section 9. Reflections on our place in the cosmos. While the scenario we've explored is highly unlikely, it serves as a reminder of the immense forces at play in our universe. It highlights the delicate balance that keeps our solar system stable. It underscores the importance of continued scientific exploration and understanding. The study of planetary collisions helps us understand the formation and evolution of our own solar system. It also provides insights into the dynamics of planetary systems around other stars. As we continue to explore the cosmos, we are likely to discover even more about the power and beauty of the universe we live in. Section 10. Keep exploring the universe. The universe is full of wonders, and every new discovery raises more questions than answers. What other cosmic events are possible? What other secrets does the universe hold? Keep exploring, keep questioning, and never stop being amazed by the wonders of space.